Hello everyone, today is day 1 of learning AI ML in few minutes theoretically. At the end of this video, you have a deep understanding of what is linear regression. And after end of this video, I will provide you the notes of this video and the homework after which you can able to write code when you complete the homework. See, 90% of the code in today are written by the AI. So you can also write code without having zero knowledge of the concept. But the main thing which company is required in hiring the people or to build your own startup is to clarity or the depth understanding of the models. So we start from scratch and in very first day we will learn about linear regression. Describing the world historically, scientists simply wanted to estimate physical quantities and understand the relationships. Can we find a mathematical rule that captures human intuition? Let's say we have data of our studies and points earned means gained marks by the students, or machinery running hours and the yield of product in the factory. This kind of data, and we want this to put or the capture mathematical rule to capture this human intuition. That is the origin to find of linear regression. Translating intuition into a mathematical rule. Linear regression formalizes human observation into a specific mathematical function. Y is equals to wxb. You can take the analogy from linear equation line. Y is equals to mx plus c. Here w is the slope, or we can say weight, and b is the intercept or the bias. Input y is the actual value or real score of the output, and y hat means the y cap is the prediction which predicted by our linear model. So when you see the equation, we have the first doubt is that okay, in the data like this, we have studied our means input x and points on with output y. We have x and y, but in this equation there are another two undefined identities means w and b. How to find it? W and b can be anything combination of 0.5, 0.2, 0.3, 0.9, anything of the real number. So how we find what is the base value of wx plus b? What is the value of w and b? Our goal is to find the exact parameters for w and b that best explain that. For this, we should understand the residual error. Error means, let's say the real value is 10 and your model predict 5. So the residual error is 10 minus 5 means 5. Let's say the value is 15 and your model predict 12. The error is 15 minus 12 and it is 3. This is called the residual error. And for finding W and B, we use this residual error. How? Before that, we understand this another, we can say, perspective of the AI research. Simply you and me see y is equals to wx plus b line as a normal equation, but AI researchers see geometry. Training a linear model is geometrically the act of projecting high dimensional data onto a lower dimensional space. Okay, so I had tell you about residual error y minus y cap, but can we use this residual error to find the best value of w and b? The answer is no. Why? Because there are infinitely combination for w and b. For every w and b, if you verify, then it will take years of year and even you can't make a single model. So for finding minimum, you should also use maths, means differentiation. Okay, if you use differentiation and you have y minus y square, y minus y cap minus y as a residual error, when you differentiate it, it converts into 0 degree, means differentiation is 0. It means when we understand that differentiation is 0 in terms of explanation given is that absolute error cancel out each other, positive and negative error cancel out each other in different dimension. So we can't use this residual error because every time the sum is 0. So how we can find the minimum value of this error and use the W and B best? So the concept of squared error comes, or concept of cost comes. cost function are nothing but it helps to find the best fit line. Best fit line is this line in which we have the minimum residual error, and minimum residual error comes when we use the best W and B. For finding W and B, the concept of cost function arises. The most famous cost function is mean squared error. As name suggests, we squared our error. Why we square y minus y cap? Y v square. See in the graph. Positive and negative error. When you squared it, it penalty area means you can see the plus 10 area and minus 10 area, and best fit line passes in between them. They don't cancel each other. So that is why we squared our error. Why optimization requires a differentiable landscapes? Choose mean squared error because it creates a perfectly smooth differentiable geometry. As I explained earlier, if we use the absolute error and try to find minima, it is very complicated. But if we use a squared function, it is very easy to find minima using differentiation because we have the smooth differentiable geometry inside it. Navigation, the optimization landscape, blindfold. This is nothing but the analogy that, let's suppose you are on the top of the hill and you want to come at the bottom of the hill. How you can do that? If you are completely blind, it means you are not allowed to see. How you do that? You will take very tiny step in that direction in which the slope of the inclination is decreasing until area of the slope means the decreasing pattern is reversed or the slope decrease stopped. You will take tiny step in this direction. So we use the same analogy inside finding the minimum in the cost function. The graph of cost function is this like a U shape. Let's say we are at any point, any of this point, and we want to come at the minima. Then we take very tiny steps until we reach this point, and after this point the decreasing area ends and the increasing area starts. So this is our minimum and we want to find that. So we should differentiate our cost function to find the minima, and that is called gradient descent. To formalize that, nu w is equals to w old minus alpha time dj by dw. dj by dw is nothing but differentiation of your cost function, means your mean squared error. Alpha is nothing but the size of your step which you take. W old is old w and w new is new w. What it means? Let's say you are at this point and you want to reach it here. At this point the value of w is 30, means your value of weight is 30. Your value of your slope is 30. Then this old weight, old slope minus you do something error and you will get the new slope which is nearer to the minima. Very tiny difference between w old and w new, but w new is nearer to minima. Then again this w new become w old and you find a new w new is more nearer to minima, then more nearer to minima, more nearer to minima, and at the point you will reach the minima. This is the concept of gradient descent. The step size alpha. Alpha is called step size or learning rate. The learning rate dictates survival. Getting this parameter right is the difference between convergence and failure. Let's say if you take a very small alpha, means that you are at here and you want to reach at this minimum, then you do very tiny step. Then your training process can run years, 10 years, 15 years. That also possible if you take alpha very small. Let's say you take alpha very fast, then your alpha take very fast, then at this point alpha come at this point and suddenly skip this point. Alpha can your program can skip the minima if you take very large alpha. So it is very necessary to take the perfect alpha for the swift convergence, and ideally we take 10%, means 0.1 as alpha. The cycle of the machine learning engine is that we start from any value of w and b. Let's say I pick 5 as a w and 3 as a b, and I predict this. Then I compute cost function, means measure how long the gas is. Then from this I compute the gradient and find new W and new V. I will update my parameters, then again predict from it, measure, compute cost, compute descent, update parameters, then again predict, compute cost, compute gradient, compute parameters, update. This cycles on until we reach at the minimum, means the compute cost reach very near to the zero. Whole story behind behind the invention of linear regression and how it works. Now it's time to understand the hidden assumption that linear regression makes. And trust me, these things are the textbook thing. It might possible that it will not help you to write in the code, and no one will ask you about linear regression. Remember, assumption linear regression makes and its failure possible might not ask to you about linear regression, but high chance that you can ask for decision trees, XGBoost, transformers, machine learning, deep learning. There are many algorithms. Why we should know the assumption behind it? Because by this we able to decide which model is best for our data. As I told you earlier, 90% of the code AI can write, but it's hard for AI to predict which model to use, which model to train. It can done by the depth understanding of each model. Linear regression is the foundation. That's what I teach you in the day one. The four hidden assumptions of linear regression or paradigm. First, it assumes that the relationship between every data is linear. Expectation you can see like this, but in reality is tilted. But our linear regression assumes that the relationship between the data is linear. Second is same effect everywhere. It means that it's assumed that when you change in the 1 unit of your input, there is a same change in the 1 unit of output. It means your slope remains same for every and each pair of input and output. And that is also wrong, but it assumes this. Third thing, linear regression assumes that you give data which are independent. Means here, these are not the data or the feature are not collinear with each other. And fourth is the random error. It assumes that the error it must be random, not like a pattern-wise error. Now we see the failures of the linear regression, and one of the most biggest failure of the linear regression is outliers. What is outlier? You can see here the very tiny dots. These are the data points, and the orange dot, which are far from this data point, is called outlier. Means the data which is not following the regular pattern is called outlier. This outlier can make our linear regression line very tilted or very fluctuated, and we get the high squared error. See the explanation. Linear regression can fail silently because mean square error heavily punishes the large mistake. A single outlier acts with immense mathematical gravity. Then the mapping the boundaries of linear paradigm means linear regression. What it means? On left hand side you see the scenarios where the linear regression can fail, and right hand side the solution of this. We use polynomial regression, decision tree instead of linear regression when it fails in the particular scenarios. When real world complexity shatters fundamental assumptions, the industry moves to the more robust architecture. When you have slightly non-linearity, polynomial regression you can use. For complex data structure you can use decision tree. Strong non-linear relationship you can use XGBoost. Image you can use CNN. Text and language you are use BERT, transformers, GPT. The extremely complex pattern you can use deep neural network. We see all these things one by one in this series. The foundation DNA model of artificial intelligence, as I told you earlier, take some random WNB, predict, measure error, compute gradients, update weights, predict, measure error, compute gradients, update weights. This is the basic architecture. Scaling mechanism to billions of parameters. The architecture is incomprehensibly complex, yet the heart of the machine remains exactly the same. It is might possible that the future data or future model predict more accurately than linear regression in many things like images, audio, and text. But the process and the fundamental is same, that every time you have some predefined parameters, you use this parameter to first time predict, then you measure error, then you measure gradient, then you update your predefined parameter, and then again use this cycle. This is the same thing you follow every time in every model. The all about linear regression. I will provide you the notes you can see below the post. And the homework is that go to the ChatGPT, Cloud, Gemini, whatever God, whatever AI tool you are using. Go there. You can provide my notes. You can learn from my notes, and then tell this AI tool to guide you for making house price prediction project. In this project, you ask AI models to learn to teach you how to write code, because writing code is I think you can learn it by yourself, but the concept you can must learn from the experienced person of this field. So I will teach you further concept also. Go to AI, how to learn how to write code. You will in this house price prediction you will apply some predefined parameters of W and D. Then you find the cost function of mean square error. Then you compute using gradient descent. Then you run this cycle again and again until the minimum output occurs. So this is all how you can learn about linear regression. In next day we will discuss about logistic regression. Thank you.